Hello friends, today we are going to learn packages and interfaces. That is next our new chapter, theory part 1. This chapter examines two of Java's most innovative features, packages and interfaces. They are called as innovative because they have introduced new in Java and they are very useful in Java. Packages are containers for classes that are used to keep the class namespace compartmentalized. What is compartmentalization? This is called because class namespace we are putting the classes separately in a separate folders. Those folders are called packages. So one package can have multiple classes and one project can have multiple packages. So if you want to access some class, you can access that particular class by providing the package name dot class name. For example, package allows you to create a class name list which you can store in your own package without concern that it will collide with some other class name list stored elsewhere. So if you want to have the class name list, for example, in a same project two times, so you can create two different packages and in two different packages you can create the class name list. So name collision will not take place. Packages are stored in hierarchical manner and are explicitly imported into new class definitions. So those are stored in hierarchical manner and are explicitly imported into new classes definition. How you have already seen how methods define the interface to data in the class. Through the use of interface keyword, Java allows you to fully abstract the interface from its implementation. So interface will be implemented by other classes who are implementing or who are writing that this class is implementing interface. You can specify a set of methods that can be implemented by one or more classes. But interface itself does not have any implementation. So it is just an abstract class, but there is one basic difference between them, but we will see it in a upcoming slides. Although they are similar to abstract classes, interface have an additional capability. This is the main difference. I have already told you. A class can implement more than one interfaces, but class can only inherit a single superclass. Abstract class is inherited in a subclass, and that subclass must be implementing or must implement that abstract class. But one subclass can inherit a single superclass only or single abstract class only. But one classes can implement multiple interfaces. You cannot have same name for more than one class in one project. So this is the introduction of packages. You cannot have same name for more than one class in one project. Same name like we have already seen that list class, but not every time you will get convenient descriptive names for each and every different classes. For example, one of your class is describing your animal, that is elephant animal, and another class is also describing the class animal, and you cannot give you are now unable to give a separate descriptive name for two different classes, two different names. So for that purpose, what you can do, you can create a separate packages, and then in that separate packages you can give separate name, same names into those classes. Imagine a small group of programmers fighting over who gets to use the name foobar as a class name. Or imagine the entire internet community arguing over who first name a class espresso. But thankfully Java provides a mechanism for partitioning the class name space into more manageable chunks which are called as packages. Packages is both naming and visibility control mechanism. Why it is called as naming and visibility control mechanism? Because you can give same name to different classes in the same project using that packages, and also when you are in Eclipse environment or in IntelliJ IDEA environment, when you are exploring the package, you can visibly easily view the different class names. Easily view the structural view of your packages and classes. You can define classes inside a package that are not accessible by code outside that package. You can also create a some classes inside inside that package that are not accessible by code outside that package. You can also define class members that are only exposed to other members of the same package. Also, you can give the default access that we have already understood in access specifier, so that these data members will be visible to only other members of the same package. This allows your classes to have intimate knowledge of each other but not expose that knowledge to the rest of the world. So they each can understand what other classes are doing, but they cannot expose that knowledge to other world. Other means outside of the package. Other world means outside of the package. Now, how to define a package? To create a package is quite easy. Simply include a package command as the first statement in a Java source file. Any classes declared within that file will belong to the specified package. What you have to do? You have to include a package command as the first statement in a Java source file. So when you are creating a Java source file, you will give package and package name semicolon, so that you are telling the compiler this file is from this package. Any classes declared within that file belong to the specified package. Package statement defines a namespace in which classes are stored. This is a namespace or a name area. This particular name area, under this particular name area, this class will be stored. If you omit the package statement, the class names are put into the default package which has no name. So by default packages, if you are not giving any package name, default package is automatically created and which will have no name, and this is why you have not had to worry about packages before now. Okay. In our examples that we have seen in practical part, we were creating a package. We were right click on the project and create new package. But if you are not giving any name to, if you are not creating explicitly any package, it will be default package by default. So this is why you had not to worry. You have not to worry when you are not creating any particular package. While the default package is fine for short sample programs, it is inadequate for real applications. For real applications, if you are creating multiple default packages, it will be very difficult for you to find out in which package you are storing which class. So it is better that you give a particular package name. Most of the time, you will define a package for your code. General form of package statement is package and package name semicolon. Here package is the name of the package. For example, the following statement create a package name called my package and my package semicolon. Java uses file system directory to store packages. So when you are opening those packages in a D drive or E drive or any particular drive in your computer, you will find that you are opening a folders and folders inside folders to find out the which packages are containing which classes. For example, .class files for any classes you declare to be part of my package must be stored in a directory called my package. Remember that case is significant. Small case, uppercase is significant, and the directory name must match the package name exactly. So directory name and package name must be matching with each other. More than one file can include same package statement. So more than one file can have the package my package name. For this example, the package statement simply specifies to which package the class defined in a file belongs to. It does not exclude other classes in other files from being part of the same package. If you are writing this line package name, this does not mean that any other file cannot have the same package as the first line of this file. Most real world packages are spread across many files. So these packages are spread across many files, real world packages. You can create hierarchy of packages. One package can have another package can have another package. To do so, simply separate each package name from the one above it by use of period. So package 1 dot package 2 dot package 3 dot class name. Like this you can write down the name. The general form of multi-level package statement is shown here. Package 1 dot package 2 dot package 3. These two are optional, but when you are creating a package 1 is compulsory. A package hierarchy must be reflected in a file system of your Java development system. For example, package java.awt.image needs to be stored in a Java AWT image in Windows environment. So you will have a folder. You must have the folder Java in that AWT in that image. Be sure to choose your package names carefully. You cannot rename a package without renaming the directory in which the classes are stored. First you have to rename the directory in which the classes are stored, and then you will rename the package. Finding packages and class path. Packages are mirrored by directories. The raises can input a question. This raises an important question. How does the Java runtime system know where to look from packages what you create? This is an important question. The answer has three parts. First, by default, Java runtime system uses the current working directory as its starting point. From that, it will search for the packages you create. Thus, if your package in a subdirectory of the current directory, it will be found. For that, for example, if you have already opened, or if your current directory in a command line, command prompt is a directory, and inside that directory a subdirectory is there, and inside that subdirectory your package is existing, then it will be easy for Java compiler to find out your package. Second, you can specify the directory path or paths by setting the class path environment variable. So you have to give the class path example, class path environmental variable. For what purpose we are creating the class path? Because this is the rule that the dot class path is for any classes you declare to be part of my package must be stored in a directory called my package. For this rule, we are setting the class path environmental variable. And third way, you can use the dash class path option with Java and Javac to specify the path for your classes. For example, consider the following: package mypack. In order for program to find mypack, one of three things must be true. Either the program can be executed from the directory immediately above mypack, or the class path must be set to include the path to mypack, or the dash class path option must specify the path to mypack when the program is run via Java. So three options are compulsory. Either the program can be executed, that is current working directory is above the my package, or the class path must be set for this to my package, or the dash class path variable option must specify the path to my pack when the program is run in Java. When the second two options are used, the class path must not include my pack itself, because it will find up to one directory dot another directory, and inside that it will find out this my pack. So it should not include this my pack. It must simply specify the path to my pack, only the way to reach the my pack, not actually the my pack. For example, in a Windows environment, if the path to my pack is C, my programs Java my pack, then the class path to my pack is C programs Java. You will not give my pack over here. The easiest way to try the example shown in this session is to simply create a package directory below your current development directory, put the class files into appropriate directories, and then execute the programs from the development directory. So what you have to do to understand this, you have to simply create the package directory below your current development directory or current working directory. Second, put the class files into appropriate directories, and then execute the programs from the development directory. This approach is used in following example. Short package example. Keeping the preceding discussion, you can try this example. Package mypack, this is the first line, must be the first line. Then class balance, it have two variables, string name, double balance. Then parameterized constructor balance, string n comma double b. Then name is equal to n, balance is equal to b. These are initializing name to variable n and balance to variable b. Then void show method, if balance is equal to 0, name dollar balance, this will be the display. Then class account balance, balance current is a array of class balance, new balance of 3. So 3 objects will be there in this array. New balance, KJ fielding 123.23. Then current one, that is second object, is new balance will tell 157.02. And then current 2, that is third object, is equal to new balance Tom Jackson minus 12.33. For 3 times iterating current of I dot show. What this show will do, if balance is less than 0, then it will printing system.out.print and name plus balance. So this is less than 0, then this will print this one. Call this account balance.java and put it in a directory called mypack. What is called a directory? In your Windows environment, create a directory named mypack. Next, compile that file. How to compile? Java C file name.java. So for our example, Java C account balance.java. Make sure that resulting .class file is also in a mypack directory that you have created in Windows environment. Then try executing the account balance class using the following command line. Java mypack account balance. Remember, you will need to be in a directory above mypack when you execute this command. Otherwise, this will not be executed. Alternatively, you can use one of the other two options described in the preceding section to specify the part to mypack. One is your class path variable setting, and another is using dash class path option with your Java and Java C. As explained, account balance is now part of the package mypack. So account balance is a Java file and now it is inside the package called mypack. This means that it cannot be executed by itself. Okay, so since you have created that file, Java file, into the mypack, then it cannot be executed by itself. That is, you cannot use this command line Java account balance because it is inside the mypack. Account balance must be qualified with its package name. That is, you should write it like Java mypack.account balance as in this example. Access protection. In the preceding chapters, you learn about various aspects of Java's access control mechanism like private and public. Okay, why we have learned only private and public? Because protected was related to inheritance. Before inheritance, we learn private and public. Private accessible to only the same class, then public accessible throughout, then protected we learn in inheritance. Protected, what is the use of protected? It is protected member is accessible to directly inherited subclass. Now we will see the default access. For example, you already know that access to private member of a class is granted only to other members of the same class. Package added another dimension to access controls. As you will see, Java provides many levels of protection to allow fine granted control over the visibility of variables and methods within the classes, subclasses, and packages. Classes and packages are both means of encapsulating and containing the same namespace and scope of variables and methods. So, what is the use of classes and packages? They are both important for encapsulating, means binding data and operation that we are doing on that data, okay, on the same object. It is binding together, containing the namespace and scope of variables and methods. So packages will be a namespace under which all classes are stored. Classes are namespace under which variables and methods are stored. So this variable belongs to this class belongs to these packages, this package is belonging to this project, and so on. Packages act as containers for classes and other subordinate packages. One package can have another package, and one package can have another classes also. Classes act as container for data and code. So whatever variables and methods you are create, that will be contained in a same class. The class is a Java's smallest unit of abstraction. You know only the class name. You don't know, or you don't worry about what is inside actually happening inside your class. So it is called as smallest unit of abstraction. You are directly using the class. You are directly using the data members and member functions inside the class. You are not worried about what is actually happening, what is actually done, what is actually written inside the class. So this is called as very small unit of abstraction. Because the interplay between classes and packages, Java addresses 4 categories of visibility for class members. So first category, subclasses in the same package. One package, in that you are having subclasses, multiple classes. Non-subclasses in a same package. Same package you are having separate independent classes. In the subclasses in same package means one package, multiple classes, both are related to each other. One class is inheriting another class, third class is inheriting second class, and so on. Second one is non-subclasses in a same package. You are having same package, and in that same package all the classes are created, but they are independent classes. So no class is inheriting no other class. They are independent classes. Third one is subclasses in different packages. You can also have different packages, in that one superclass is defined in one package and its subclass is defined in another package. So this way subclasses separated or spread in different packages. Classes that are neither in the same package or nor subclasses. Fourth one is independent classes that are not related to another classes in another packages. Each class is separate. They are neither in the same package or nor the subclasses. The three access specified private, public, and protected provide a variety of ways to produce the many levels of access required by these categories. Private, public, and protected provide a variety of ways to produce the many levels of access required by these categories. Private gives you what? Access to same class, not outside the class. Public gives you what? Access throughout the project. Protected, access to the directly inherited subclass, not second class that is directly inherited. Means if B class is inheriting A class and its protected members is accessible only to B. If C is inheriting B, so C cannot inherit the protected member of A. So in multi-level inheritance, protected will always only give you access to the directly inherited subclass. While Java's access control mechanism may seem complicated, we can simplify it as follows. You may get confused sometimes that what is happening over there. You may find it complicated unless you are not practicing it. Unless you are practicing it, if you are daily practicing it, you are daily reading it, you are daily learning and remembering the things, you are understanding it thoroughly, then it is very much easy to understand. In Java or any other programming language, more you practice, more you understand, and more you practice, more you learn, and more you remember. The only reading part is different. When we are reading theory, when you are not known or we are clearly a newbie in any particular language, we don't know anything about any that particular language. But when you are already knowing the theory, reading that theory again and again, it's not of use. So what you have to do, you know the complete theory of access specifier, for example. So unless reading them again and again, to not feel the access specifier complicated, for example, for this example, what you have to do, you have to create Java programs, you have to use those access specifiers. For example, you have 4 access specifiers, right? Private, public, protected, and default. What you will do in this case, you will create a big program, big project. In that you will create multiple packages, and here they have given different options. First is subclasses in the same packages. So you will create one superclass, multiple subclasses. In this case, you will create one superclass and different classes that are not dependent classes. Third class in one superclass in one class, then another subclass in another package, and independent classes in different packages. So do these things. You have to implement these things. You have to practice these things. And here use different access specifiers. After that, you will understand what is the difference between all those access specifiers and what is the actual use of it. When you will build the actual real world Java applications, you will understand the actual usage of this. But still then, what you have to do, you have to practice this again and again. Only reading theory is a different part, and practicing again is a different part. And one more important advantage of practicing is you enjoy the process. You enjoy the learning process. You enjoy the production process. Programming, after programming, you are creating the output. Creating output is like you are producing something. You are having some end output. After that end output that you are for example, you are creating your own program, and without error you are getting the output without anybody's help. That joy, that that satisfaction is different, that cannot be explained in words. So you have to practice it again and again. Okay, so why I am telling you these things? Because this is that this line is written that may seem complicated. It is not complicated. Anything that you are learning may be complicated, but till you are not practicing it. You are practicing it, you become master in that. Okay. Anything declared public can be accessed from anywhere. You have to learn, you have to understand, you have to note down these things. Anything declared public, write down, public can be accessed from anywhere. Anything declared private cannot be seen outside of this class. Now, class member access. This chart is very important. You can take a printout of this. You can take a screenshot of this. Otherwise, you can take a paper and pen and write down this. This is very important thing. Okay, so you have to take a paper and pen, note it down, or you can take a photo. You can learn it. You can understand it. Okay, so first thing, private member. Accessible in same class? Yes. No modifier. Default access. It is accessible. That member is accessible in same class? Yes. Then protected member. Accessible in same class? Yes. Public member accessible in same class? Yes. Then private member. Accessible in same package subclass? No. Default access? Same package subclass? Yes. Default same package subclass protected member? Yes, of course. Public? Of course, at any time. Then private, same package, not subclass. Private is not accessible anywhere. No modifier, default access, same package, no non-subclass, that is independent class. Yes, of course. Protected member, same package, no subclass. Yes. Public, same package, no subclass. Yes. Private member, different package subclass. No. No modified default access, different package subclass. No. Protected member, different package subclass. Yes. Public member, different package subclass accessible. Yes. Private member, different package non subclass not accessible. No modified default access member, different package non subclass. No. Protected member, different package non subclass. No. Public member, different package non subclass. Of course, public is accessible everywhere. Okay. When member does not have explicit access specification, it is visible to subclasses as well as two other classes in the same package. Write down the line, same package, not outside of the package. This is the default access. If you want to allow an element to be seen outside of the current package but only to classes that subclass your class directly, then declare that element protected. You want your element or your data member function to be seen outside of the current package but only to subclasses that your class directly inherited subclasses, then declare that element as protected. Table allow above applies to only to members of the classes. Non-nested classes has only two possible access level, default and public. Access example. This is the example that shows all combination of the access control modifiers. This example has 2 packages and 5 classes. Remember that the classes for the 2 different packages need to be stored in directories named after their respective packages. In this case, package 1 P1 and package 2 P2. The source for the first package defines 3 classes: protection, derived, and same package. Source for the first package defines 3 classes: protection, derived, and same package. When a class is declared public, it is accessible by any other code. If a class has a default access, then it can be only accessed by other code within the same package. When a class is public, it must be the only public class declared in a file, and their file name must be same as the class name. Your Java file is, for example, abcd.java. In that, it must have one public class called public class ABCD, whose name should exactly match. Exactly means exactly. If A is capital, B, C, D is small, then file name also should be A, B, C, D is small. If A, B, C, D all are capital and your A, B, C, D all should be capital in a class. So every Java file must have only one class with the same name as a Java file. It is very, very important line. The first class defines 4 integer variables in each of the legal protection modes. Variable n is declared with the default protection, and private is private, and protection is protected, and public is public. Each subsequent class in this example will try to access variables in an instance of this class. So it will try to access and it will try to explain you. The lines that will not compile due to access restrictions are commented out. So compile time error giving code, it's commented out already. Before each of these lines is a comment listing the places from which this level of protection will allow access. Before each of these line, each comment is a comment listing the places from which this level of protection would allow access. The second class derived is a subclass of protection in the same package P1. Protection subclass is derived in a same package P1. This grants derived access to every variable in the protection except for the n private and private one. N private is a private, so it cannot be accessible outside the class, not the subclass also. The third class sample package is not a subclass of protection but is the same package and also has access, but n private. N private is not accessible. It is a separate class, independent class, same package. It is not inheriting any other class. It is an independent class and it is in a same package P1 and also has access to all variables, but only not n private. Protection.java. In protection, n is equal to 1, n private 2, n protected 3, and public 4. Base constructor, private, protected, public. Same class, access to all variables is granted. Derived.java. Derived inherits protection class. It extends protection. Derived default constructor, derived constructor, n is there. N private, this line will not compile because this is a private variable, so it is commented out. N protected, n public, it is accessible because this is the derived class. It is a directly inherited class. Same package. Same package is independent class. It is not dependent on anyone. Protection P is equal to new protection. Same package constructor. Here we have created object of class protection. This is the super class. N is equal to protection dot n. So it can access that variable. Then n protected. This n private is not accessible. This is a private variable. N protected is accessible. N public is p dot n public is accessible. Following the source code for other package p2. Now we have completed the same package. Now we will go to the other second package, that is p2. We have 2 packages and 5 classes. The 2 classes defined in p2 cover the other 2 conditions that are affected by access control. First class protection 2 is a subclass of p1 dot protection. So protection class is written in package 1 and protection 2 is written in package 2. But protection 2 inherits the p1 dot protection. This grants access to all of p1's protection variables because it is directly inheriting class except for n private variable. And n, the variable default declared with the default protection. Default is accessible to the outside of packages also, but only to subclasses. We have what we have seen, what I have told you, that when the access is default, that data member is accessible to only the same packages, not outside of it. But in this case, protection is a class, superclass in package 1. Protection 2 is a subclass of protection which is written in package 2. And it is directly inheriting that class, and still it is in second package, it can access the default member written in protection class. It is exception for default access. The default only allows access from within the class or the package, not extra package subclasses. Default only allows access from within the class or package, not extra package subclasses. Finally, the class other package has access to only one variable n public, which has declared as public. Protection2.java. Protection2 extends p1.protection. Protection2 default constructor derive other package constructor, class or package only. N is used here. So we will see n is declared as integer n is equal to 1. It is a default access. Now, class only private and protected public. Then other package.java, it inherits only one variable, that is public. p1.protection p object is created is equal to new p1.protection. Other package constructor, class or package only, system.out.println n is equal to p.n. Then class only, class subclass or package only n public variable is accessible. p.n public. This is the default access, not outside this package. This is the private access, not outside the class. This is a protected access, not for the non-inherited classes, and here the public access. If you wish to try these 2 packages, here are few test files you can use. Demo package p1, package p1 instantiate the various classes, public class demo. So here we are creating objects for protection. ob1 is equal to new protection, derive ob2 is equal to new derive, and same package ob3 is equal to new same package. You don't have to write anything, because in the constructor itself we have created the objects, and that objects are accessing and displaying the data. So you don't need to create anything else. Okay, in that here also we are creating the object. In this example, here also we are creating object, and we are directly using the dot operator and displaying the value. So in main method, you just have to create the objects of main classes. One class is protection OB1 new protection. Derive OB2 is equal to new derived. Same package OB3 is equal to new same package. Test file for P2 is shown next. Public class demo. This is for what? Package 2. Protection 2 object 1 new protection 2. Other package OB2 new other package. Importing packages. Given that packages exist and are a good mechanism for compartmentalizing diverse classes from each other, it is easy to see why all of the built-in Java classes are stored in packages. Why we are storing them in packages? There are no core Java classes in the unnamed default package. Every package is named in Java. All of the standard classes are stored in some named package. Since classes within a package must be fully qualified with their package name or names, it would become tedious to type in the long dot separated package name for every class you want to use. For example, one package in Java can have multiple packages, and if for any particular class, that is a built-in class, if you want to use it, what you have to do, for example, class ABCD is written in package 1 dot package 2 dot package 3 dot package 4 dot package 5. It is written in package 5. Then it will become tedious for you to remember the names for all the packages and then your ABCD class. What you have to write? Package, import P1 dot P2 dot P3 dot P4 dot P5 dot ABCD. You cannot write it like this for a very long name packages. For that you will use a star. For this reason, Java includes import statement to bring certain classes entire package into visibility. Once imported, the class can be referred to directly using only its name. So while importing, you can also use a star. And if you are not importing, you would have to write the complete name. But Java have invented or introduced the import statement. So whatever class that you have to use, that is inbuilt class, you just have to import it and use it anywhere in your entire class. The import statement is a convenience to the programmer, and it's not technically needed to write a complete Java program that is already defined. If you are going to refer a few dozen classes in your application, however, import statement will save a lot of typing. In a Java source file, import statements occur immediately following the package statement if it exists. So first of all, package statement will be the first statement. After that, any import statements will be there, and before any class that you are creating. This is the general form: import keyword, then package name 1 dot package name 2 dot package name 3, and so on. After that, class name or star. If you are giving a star, all classes from that particular package will be imported into your code. What is importing? It will include your inbuilt Java class, Java file, and in that inbuilt class, say for example, you are importing the math class. If there are some methods like square root already defined in a math class, so you no need to define your own math functions in your class. So you just have to import that math class in your project, in your Java file, and then you can use that function square root in your class. Here package 1 is the name of the top level package, and package 2 the name of the subordinate package inside the outer package separated by a dot. So one package name dot, another package name dot, another package name up to another package end. There is no practical limit on the depth of the package hierarchy except that imposed by the file system. So there is no limit how much hierarchy you are providing. Finally, if you specify either an explicit class name or a star, which indicates that the Java compilation import the entire package. Import java.util.det, import java.io.star. The star form may increase compilation time. If you are giving the star means you are importing all the classes from this package. What happens in this case? You have to be alert. All the classes will be imported. Okay, at the compile time, whatever classes you are writing in your project, all classes including default classes will be compiled. There is no need to actually implement or compile the already defined classes in Java class libraries, Java packages. They are already defined. For example, java.io already defined, math class is already defined, date class is already compiled and run. It is no need. But as a rule, compiler, what the compiler will do, it will compile all the classes that you are importing also and you are writing also in your project. So it will increase the time required to compile your complete project. Many more classes, the more running time, more compilation time will increase, especially if you import several large packages. For this reason, it is a good idea to explicitly name the classes that you want to use. If you are giving star, all the classes will be imported. For example, in some package named P1, there are 15 to 20 classes are there, but you don't remember the class name exactly that you want to use in your project. So what you will give, you will give complete star. So that star will import all the 15 to 20 classes. But actually you are requiring only one class, and all the other 19 classes will also get compiled, and it will increase the compilation time. For that purpose, what you have to do, you have to avoid writing the star as many times as you can. You can avoid it so that you try to remember it if possible, so that it will reduce your compilation time. For this reason, it is a good idea to explicitly name the classes that you want to use rather than importing whole packages. However, the star form has absolutely no effect on runtime performance. So runtime performance will not be affected if you are giving any star, but compilation time will be increased. And star form, not star form, will affect your size of your class. Size of your class will remain intact. So if you are importing suppose 20 classes, all the other classes MB, how much MB size is there, will be increasing your project size? No, it is not the case, and it will not affect any runtime performance. But still, if it is possible, please try to avoid the star. Try to remember here in this example, instead of writing java.util.star, right, it is okay that you are writing java.util.date, because date is a single class that you are requiring in your project. But java.util.star will import many more classes. There are many classes in java.util. So all those will get compiled, and it will affect your compilation time. All of the standard Java classes included with the Java are stored in a package called Java. Main file is Java. The basic language functions are stored in a package inside of the Java package called java.lang. So very basic package is java.lang. You have to import every package or class that you want to use, but since Java is useless without much of the functionality in java.lang, it is simplicity imported by the compiler for all programs. Whether or not you are not importing the java.lang, it is implicitly imported by the Java compiler for all the programs you are creating. This is equivalent to the following line being or at the top of all your programs: import java.lang.star. All the functionality is written in java.lang. So for this case, what will happen? All the classes will be imported from java.lang. It is not compulsory for you to write, because whether you are not writing this line, Java compiler will automatically write this line for your classes. Import java.lang. Why? Because it is useless. Java is useless without much of the functionality in java.lang. This is the main package. Okay. This way we have finished the theory part 1 of packages and interfaces. In the next session, we will try to complete all the remaining topics in packages and interfaces, and afterwards we will try to implement in a practical part. So meet you in the next session. Thank you so much.